All right, so let's work through our final review. Now, I need you to listen to me very carefully. The problems are worked in order, but because these are problems that I have already worked in other reviews throughout the year, I cut and pasted those slides into here. So the numbers may not match up. So number 10 may have like number 20 on it. The thing is, I didn't realize that until I was almost done with the whole review, and I don't want to go back and fix it. Okay, so you're going to be smart enough to know which is which because they go in order and there's only one of each type, I think. Number 1 is just using order of operations. Remember, parentheses, exponents and roots, multiply, divide, add and subtract. So I honestly did this in a weird way. I actually solved this and this in the same step because this is outside of the parentheses, and while I was doing this one inside the parentheses, I did that. Now I'm going to finish inside the parentheses. 3 plus 1 minus 2 is 2. So there's my parentheses done, and I did my roots all at the same time. Now we do our exponents, which is right here. And remember, what's happening between these two things is multiplication. Two things side by side means multiply, which means once I solve that 2 squared, I have to multiply that in. Now this is the part if people make mistakes on here all the time. When you're taught this PEMDAS, multiplication is listed first, but you have to remember that multiplication and division, addition and subtraction are both done together from left to right. So even though multiplication is written first, we do not do that part first. We are going to divide first because we multiply and divide together from left to right. So 26 divided by 13 is 2. Now I multiply, and I actually have two things here from left to right, so I'm going to do 2 times 3 and 3 times 4, which gives me 6 plus 8 minus 12. Now I add and subtract together from left to right, so 6 plus 8 gives me 13. 13 minus 12 is 1. So that's order of operations. All right, number 2 tells us to evaluate 3t squared minus t plus 10 if t equals 2. Now these are easy, all right? All we have to do is replace our t's with this. And I always use parentheses, and I'm going to tell you to do the same thing. Number 1, that way I don't lose my operations. Number 2, that way I don't lose my signs. Because if that was a negative I was plugging in, I would not want to, I don't want to lose my negatives. And now we just use order of operations. Well, 2 squared is 4. And don't forget that we're multiplying between that 3 and that 2. So when the 2 squared becomes a 4, you have to continue to multiply. Now I'm going to multiply. So 3 times 4 is 12. Negative 9 times 2 is negative 18. 2 minus 18 is negative 6. Negative 6 plus 10 is 4. And that's it. Just plug in the variables. Nope, the values for the variables. All right. C is talking about multiplying and dividing terms. And remember, a term is just a group of coefficients and variables. And it can have exponents in it as well. What you need to remember is when you're multiplying and dividing terms, the coefficients, which is the letter in front of the term, or at the beginning of the term, if you're multiplying, you multiply those coefficients. If you're dividing, you're dividing the coefficients. The operation for the big numbers doesn't change. However, when you're multiplying, remember you add exponents. When you are dividing, you subtract exponents. That's only for exponents, remember. Coefficients or the big numbers, you do what the operation tells you. So here's an example. This tells me 3c3 times 9cd squared. We're multiplying. How do I know that? Two things side by side means multiply. 3 and 9, those are the coefficients. I multiply those because that's the operation happening. 3 times 9 is 27. And then c3 and c. Do not forget the understood 1 with that c. So 3 plus 1 is 4. And then there's no other d's, so that d squared stays. So what I have in my total answer is 27c4d2. If I was dividing, then I would just subtract. That'd be 3 minus 1 instead of 3 plus 1. So multiply, add exponents, divide, subtract exponents. Let's talk about solving for an unknown, means solving for x. It's almost always x at this level. Step 1 is to distribute. Anything that needs to be distributed in, you need to do that first. Then you're going to add or subtract any like terms so that you have it all simplified before you start moving things around. Then you're going to move your variable terms to one side. So anything that has an x, so you're going to move all of your x's to one side. We like x on the left. It's just the way our brains function. So if you'll move all your x's to the left, then move non-variable terms to the other side. So any variable, or any term, sorry, that does not have an x, so any numbers, move to the other side. Usually we have x's on the left, regular numbers on the right. Remember, when you're moving them over the equal sign, the operation changes. Then you're going to add any like terms you have again. And some people sort of do that as they move them, which is fine. Then you're going to divide or multiply. 90% of the time you're going to divide to get x by itself. Occasionally you'll have to multiply. Let's walk through an example of this. All right, so remembering the steps we just went over, we're going to work through this one. So the first thing we're going to do is simplify however we can. I can't do anything inside of my parentheses, either one of them. So I'm going to look outside. This 9 is going to go to every piece in that parenthesis. Remember to stop when the parenthesis ends. That's where the multiplication process ends. And then do the same thing with the 5 here. So 9 times x is 9x. 9 times negative 2 is negative 18. Minus 1 equals 5 times x is 5x. 5 times 1 is 5. So I've simplified by distributing. Now I'm going to do any like terms. So I have a negative 18 and a minus 1 on this side. I'm not touching the 9x. Negative 18 minus 1 is negative 19. And then I have no like terms on this side. Now we're going to do x's to the left. Numbers to the right. Remember, when we move them, the operation changes. So my understood plus 5x becomes a minus 5x. My minus 19 becomes a plus 19. Now I'm going to add any like terms. 9x minus 5x is 4x. 5 plus 19 is 24. I'm going to move this 4 over. When I do that, it switches from multiplication to division. 24 divided by 4, x equals 6. The last step of this review is about radicals, and a radical is that square root sign. We say square root, but it can be a square root, a cubed root, a fourth root, any of those. Those are our radicals. And there's several things that we do with radicals, so let's walk through the how-to of each of these real quick. Number 1, if we're told to solve for a variable, means solve for x, the steps are, number 1, you're going to isolate the radical. We're going to work through a couple of these, so make sure you write these down, and then you can write the examples down. Isolate means get by itself. Then you're going to add any like terms. You have to make sure you add your like terms and isolate your radical first. Then you're going to square both sides. And the reason we have to square both sides is because, well, maybe I shouldn't say square. If it's a square root, we square both sides. Later, if it's a cubed root, you would cube both sides. For today, or for this lesson, we're just squaring both sides. The reason we're squaring both sides is because a square undoes a square root. So they're inverse operations. And then you just solve. Once you square both sides, the radical symbol disappears, and then you can solve. We'll do one of those in a second. The second thing that we're going to do is we're going to work with fractions with radicals, and here's the rule. You cannot have a radical in the denominator. And so to isolate that or to undo it, you simply multiply the top and bottom by the radical. We'll do one of those. And then multiply, you simply whole number times whole number, radical times radical. To divide, whole number divided by whole number, radical divided by radical. And then at the very end of any of these problems, you have to simplify. And to simplify something, you break it into its prime factors, you find any pair, each pair pulls out as 1, and then you leave the leftovers. Now, have those written down somewhere, and then we're going to work through a couple of these. So if you need to pause the video to have these written down, that's fine. So let's work through this one. Let's solve this for x. So the first thing I have to do is isolate the radical. Remember, that just means get the square root symbol by itself. That's really easy to do. I just move everything away from it. My plus 3 is going to become minus 3. And then go ahead and simplify whatever you can. So 9 minus 3 is 6. So I've isolated the radical. Now, in order to get rid of my square root sign, I square it. But remember, because it's an equation or an equal sign there, I have to do to both sides to keep everything equal. So isolate the radical, square root both sides. When I square root the left side, it simply makes the radical symbol go away. Like I said before when we did this, you can actually work all of this out and take all of that time, but just know you're going to end up at the same place as just dropping the radical sign. And then 6 squared is 36. Now I just solve for x. Move my 20 over, it becomes plus 20. Move my 7 over, I'll just write this down. I'm multiplying on the left, so I divide on the right, so x equals 8. Isolate your radical, square both sides, solve for x. Let's work through these two. Now, here's the thing. It's mathematically illegal to have a radical in your denominator. You can't do it. You can't leave it there. So in order to eliminate that radical sign or that square root sign, if I multiply a square root by itself, for example, square root of 4 times the square root of 4 is the square root of 16. Square root of 16 is 4. Square root of 2 times the square root of 2 is the square root of 4, which is 2. Radical times a radical eliminates the radical. But whatever I do to the bottom, I have to do to the top. So square root of 13 times square root of 13 is just 13. On the top, I have 5 times square root of 13, and because those are different forms, it's almost like an x and a no x term, I can't combine them. 5 and square root of 13 are not in the same form, so we simply write them side by side, and that's the answer. Now on this second one, we're multiplying. Now I always look inside my parentheses, and I can't do anything with this because they are not like terms. They're not the same form, so I can't add them. So what I now have to do is distribute this. Square root of 6 times 4 is 4. Square root of 6. Square root of 6 times square root of 3 is the square root of 18. Now, if I ended up with like square root of 25, I would simplify that down to 5. In this case, there's not a square root of 6. There's not a square root of 18, but I need to simplify it. So the way I'm going to simplify it is I'm going to break it down into its prime factors. This is 2 times 9, 3 times 3. And I'm going to kind of rewrite this. And because I have square roots, I need to look for any pairs that I have. There's no pairs in this first term, so it's going to stay 4 square root of 6. Nothing matches to pull out. However, in this last one, I have a pair of 3's. Those pair of 3's are going to pull out as 1. Square root of 3 times the square root of 3 is 3. And that leftover is going to stay in. And because my radicals don't match, this is where I have to stop. If I was dividing these, I would just divide the terms instead of multiplying, all right? So finish up the problems on this, work through the other reviews. Remember, your review packet is for half of your test grade, so get it done. So what we're going to do when we divide this, we are going to rewrite this kind of spread out. So 60 break up your radicals. So I'm going to go ahead and just tree this in my brain. 30 divided by 2 is 15. 15 divided by 3 is 5. So there's 30 broken up. 6 broken up is 2 times 3. Now, so step 1, tree it. Tree your radicals. Now remember, the radical is the correct term for the square root symbol. Now, coefficients are just numbers, just do what it says. 60 divided by 5 is 4. And then under the radical, you can cancel. 2 over 2 becomes 1. 3 over 3 becomes 1. And because we're multiplying, those ones change nothing, so all that's actually left is square root of 5. So, spread everything out, tree the radicals, simplify your coefficients, or your whole numbers if that makes sense, then cancel whatever you can. And then that's my answer. So remember, these are not hard. You just have to remember 2 things. When you have an exponent or an exponent that is a fraction, the top represents the exponent, the bottom represents the radical. So I'm going to rewrite this with a radical symbol. With the base number, the 2 becomes the exponent. Your numerator is the exponent. And that 3 is what's called the index inside of that radical. And now I can simply solve this. But I'm going to have to pull my calculator out because that's a big number. So the 125 squared is 15,625 cubed rooted, and then let me see if I can get my calculator to work with me here to solve for that. So when I do the cubed root of 15,625, I get 25. So that simply simplifies down to 25. So in your notes, make sure you write down that the numerator is your exponent, the denominator is your radical, technically the index of your radical. So, sorry, my children, we're going to graph this one. So remember, we're going to line this up with y equals mx plus b. 4 is b, m is negative 2/3. We graph our b first, then from the b, we rise over run. And I should have cut and pasted a graph in here, but there we go. So remember, the b is the y-intercept. So on the y, we're going to put a point at 4. Then from the b, from that point, we're going to go down 2 because it's negative. But we always, always, always run right. And we're going to run 3 points. So we're going to go down 2, 1, 2 over 3. And this is the part I can never do on this pad. And there is my line. Simple as that. The next part is finding the slope. And remember, there's an equation to find the slope. And it's m equals y2 minus y1 over x2 minus x1. So here's 2 points you're given. You have 2 sets of coordinates. There's 2 points. Remember, your first is x, your second is y. This is set 1, this is set 2, and you just fill that in. y2 minus y1 over x2 minus x1. The one thing you need to pay attention here is if you have a negative value, make sure you watch that, because remember, minus a negative becomes a plus. So we just solved this. 3 minus 2 is 1, 5 minus 3 is 2, and that's my slope. It's real simple. As long as you remember y2 minus y1 over x2 minus x1. Let's talk about point slope form. Point slope form, remember, is y minus y1 equals m times x minus x1. Remember, x and y stay x and y. x1, y1 are the x and y values from the point that you're given. So you're going to be given the slope. You're going to be given a point. You're going to be told the slope of a line is this, and it goes through this point. And those are just the values you're going to plug in. M is obviously M. The slope is M. And then remember, it's always x, y. So literally all you have to do is plug those values in. And for right now, we're going to leave it like that. Later on, you will take this and manipulate this formula to get somewhere else. But for right now, that is it. So y minus y1 equals m times x minus x1. That is the point slope form. Last point for this review. So this is going to be a really short review. Probably longer for you because you're probably hopefully pausing it and writing notes down. But parallel and perpendicular lines. Sorry, I just slurped my water in the microphone. So if it is a parallel line, so if you're given two sets of lines, nope, one set of line, a set of two lines is what I'm trying to say. You can tell if those lines are parallel or perpendicular. If they have the same slope, they are parallel. If their slope, so mathematically in the mathematical vocabulary, if the slope is the negative reciprocal, basically if it is the negative flipped fraction, reciprocal is just the flipped fraction. If it is the negative flipped fraction, it is perpendicular. If it's neither one of those, then they're oblique, they never hit, okay? Literally all you have to do on the problem like this is to look at your two lines, and all you even need to do, or your two line equations, I'm sorry, is look at the slope of those two lines. So here's a problem, and you're asked, is the line parallel or perpendicular? So all I need to do is look at my slope. All that matters for parallel or perpendicular is this information right here. If they are the same, they are parallel. If it is the negative reciprocal, so if I have 1/2, the negative reciprocal is -2/1. If I have -3/5, the negative reciprocal is +5/3. If it's the same, it's parallel. If it's the negative reciprocal, it's perpendicular. Well, these guys are the same, so they are parallel. That's it. That's the last part of this review. Go through everything, do the problems that I did not do, and make any notes that you need so you're ready for the test. All right, so I have everything up on this one slide because I couldn't figure out how to make one piece come at a time because they're side by side. And now that I'm speaking it out loud, I know what I could have done, but it would have taken me a lot longer. So here's what you have to remember. These lines mean absolute value. And remember, the absolute value of a number is simply how far from the origin that number is. So it's just going to be the positive version of it. But here's the thing about absolute value. The absolute value of -4 is 4. The absolute value of +4 is 4. So I can get the same value for the negative input of a number and the positive input of a number. I can have a negative or a positive absolute value and end up at the same place. So in order to compensate for that, I have to split this into two problems, one positive and one negative. And then I distribute that positive and that negative out, and we know that a positive outside of our parentheses changes nothing, and negative outside changes the signs. And then, we just solve these absolute values, that's not the right word, we just solve these inequalities as if they were an equal sign all the way down, and you can see what I did. I moved my -7 over, nope, I didn't do that, sorry. What I actually did was simplify first, then I moved around. The only thing you have to remember is if I divide by a negative, my symbol flips directions. So right here, I'm dividing by a +9, so my symbol stays. Over here, I'm dividing by a -9, so the direction of my symbol switches. So if you have an absolute value, split it into two problems, a positive and a negative. Solve it then just as if it was an equal sign. Only remember, if you are dividing by a negative, flip the direction of the sign. This part is graphing inequalities, which sounds scarier than it is, but it's really not that hard. So you're going to be given an inequality. It may not already be in this form. Like, you may need to distribute some things out. So if I had this, I could distribute this 2 out. And now I have an equation that I can graph. Your textbook has you t-charting things and finding points. And the simplest way to do this is to eliminate all those t-charts, eliminate all those things, and just graph y equals mx plus b. Now before you can do that, you may need to do some manipulation like I did right here, okay? And we're going to just graph this as if it was an equal sign first. Y equals mx plus b. Here's my b. I don't know why that has a 1 there. That should say y equals mx plus b. Remember, b is where it crosses the y-axis. So in this case, it crosses at -1. From there, we're going to rise over run. And we had a problem like this in homework, and several of you were confused. Remember, there's an understood 1 there. And to force it to be a rise over run, we need to put it over 1 to create a fraction. So don't forget those understood 1s. From the b, we're going to rise 1, and we're going to run 1. And because it's positive, we rise up. And here's what we have to remember. If it is greater than or less than, my line is a dotted line. If it is greater than or equal to, less than or equal to, it is a straight line. And in this case, y is greater than, so first of all, it's a straight line. So I can do that. And then the second thing we need to know is it is greater than. So basically what that means is the value that I'm looking for is anywhere above that line. I just absolutely did that wrong. I did a solid line, and it needs to be a dotted line because it is not equal to. Okay? Now, anything, what it's saying is y is somewhere above that line, somewhere greater than that line. So what we're going to do is I'm going to use my highlight thing on here to make it bigger. We've got to highlight above the line because it's greater than. If it was less than, we would shade below the line. So put it in y equals mx plus b form first. Then graph it. Remember, if it is greater than or less than, you're going to use a dotted line. If it is greater than or equal to, or less than or equal to, you are going to use a solid line. If it is greater than, you're going to shade up. If it is less than, you're going to shade down. But don't worry about all the t-charts. Just put it in y equals mx plus b form and graph. Adding and subtracting linear equations. Now, this is actually already set up for you. Your textbook gave these to you set up. Your test is going to give these to you set up. And we're going to just add straight down. The only thing you need to remember is if it is a, let me get my pen to work, here we go, a minus, say this, that minus is going to change the sign of everything. So just watch for that minus. If you're subtracting it, it changes the sign of everything. Make sure you do that before you add up and down. Now, it's really easy. Just go straight down. 7x squared plus 5x squared. Oh, I've already done it. I forgot. 7x squared plus 5x squared is 12x squared. Remember, when you're adding, you don't change the term. And then negative 8x plus 4x, remember to keep your sign with it. Negative 8 plus 4 is negative 4x. Then 6 minus 7 is negative 1, and that's it. Only thing you need to do is watch for those negatives, and that negative changes the sign of everything inside of your parentheses, and then just add down. And the most tedious one that we've done, for the last thing that we've done, we're solving sets of linear equations. And remember, well, I don't know if you remember or not, but what you're doing is you're going to be given two equations of lines. Now, these are not in the y equals mx plus b form, but we know they're linear equations because they have an x and a y. And I apologize if you hear the kazoo in the background. My children got kazoos today because I like misery, I guess. I don't know. So you're going to be given two equations. They're going to be connected. They're technically linear equations. And basically what we're going to do is we're going to solve for the point of which those two lines intersect, that point where they cross. And there's a ton of ways to solve it. The first way this textbook teaches you is to add them. And so what we're going to do is we're going to line them up like we just did into an equation, or into a set that we can then add straight down. Negative 3x plus 3x, that x goes away. Negative y plus 2y gives me 1y. Negative 24 plus 12 is negative 12, equals 0. And now we just solve for y. So I need to move that 12 over, and it becomes a positive 12. And 1y is the same thing as y, so y equals 12. Now I did that really quick on this problem. I know. Take this all the time that you need to do it yourself. So what we've done is we have made it an equation. That's not technically the right terminology, but Q-U-A-T-I-O-N, and we have just added it down. The second thing we did was we solved. If you have an x left, solve for x. If you have a y left, solve for y. Then the third thing that we have to do, these are really tedious. The math is not hard on these, but they're kind of tedious, is that value that we just solved for, we're going to plug it in. So I plugged it into this equation. You can plug it into either equation. I picked this one because the 3 was positive, and I just think positives are easier to work with than negatives. And because we solved for y being 12, I put a 12 right there. So 3x plus 2 times 12 plus 12. And now I just solve for x. 2 times 12 is 24. 24 plus 12 is 36. Now I need to move that 36 away from the x. When I do, it becomes a negative. Divide by that 3, and I get x equals negative 12. So I have an x value and I have a y value. And remember, we're solving for the point that those two lines intersect. So our answer needs to be in a coordinate set, an x, y set. Remember, it is always, so I guess technically I could do this. Put it in the x, y form. X is always first. All right, that's everything on the review. Make sure you have all of the notes. Make sure you've worked the problems that I haven't worked with you, because that is half of your grade. Do not forget a calculator, because you will not be allowed to use a phone calculator. And if you know me very well, I will not let you have a phone calculator, even if you come at me and tell me you forgot it. So remember your calculator. So this video is already at about 33 minutes. So we're going to stop this video here, and then I will do a second video to work the rest of the problems. If I make a video much longer than this, I will never ever get it to upload. So we're going to end this one here. I will link both videos in the assignment.